Hello. On this part we should find and interpret the area under a normal curve. Here on this part we have z-score. We had this part before. Z is equal to x minus this is what the value is, and here is mean, and this was standard deviation. So what z-score is, so I'm writing that here. So this z-score, what that means is how many standard deviations from the mean. So that is what z-score means. And also, you can say that, okay, when we have z-score, that means that we want to find the area under a normal curve. So, and also this one was our value. Okay, now example number 3, find the indicated areas. Part A, so we need to find area to the left of Z. Z is 1.33. So let's say, if you remember, we know that here and this part we have mean. So what that means here on the left side, KF, so since that z-score is 1.33, if that was here, 1.33, we need to find what the area is on this part, so all these. So based on that table here, area, instead of area, we can also write proportion or probability. So that area, which was what we had here on the left side of z-score, is equal to 0.9082. So this is our area. Now part B, we need to find the area to the right of z-score. So here is our z-score, so z is 1.33, and we should find the area on this side, which is on the right side of the z-score. To find the area to the right of z-score, we need to follow this rule. So the area, I'm writing that here, so not. The area to the right of z-score That is equal to 1 minus, but this one is, as I said, the area is equal to 1 or 100%. So 1 minus the area to the left side of z-score. So the area exactly same thing on this part. So the area, this is the area to the right. That is equal to 1 minus what we have on left, which was from part A. The area to the left was 0.9082. So this was left. So what the answer is 0.0918. So I'm writing that for part B. So just remember that when you have right, you only need to subtract 1 minus what you have on left. So subtract it from 1. So now here we have right of z equal to 1.33. And that is equal to 1 minus area to the left of z equal to 1.33. So the answer is 1 minus 0.9082. This is from part A. So subtract the answer for part B as 0.0918. Okay, now part C. We need to find the area between these two z-score. And the first one here, z is 0.02 and here is 1.33. So z between 0.02 and 1.33. Okay, trying this one. For this part, showing how we can find the area between these two z-scores. Okay, so in between for a normal random variable for this part, when you have this, we always have mu equal to 0. So what we have on top here, here mean is always 0. And for this part, when you have a standard, and when you have a normally distributed, and standard deviation is equal to 1. So I'm using that one here for part C. Here we have 0. And our z-score is 0.02. I'll say that it's over here. Okay. So here is 0.02. 0.02 up to 1.33. I'm not sure exactly where that is, but I'm working based on what we had here on this board. So I'll consider that that line is here on this board. So now we want to find the area in between, so the area for this part. And now here we can use this table and find out. So here, as you can see, here we have z-scores, and this column we have starting from 0, and in this part we need 1.33. So here is 1.3. So going to right, going up, here is 0.03. So adding these two, we have 1.33. But that means the answer for this part, the area is 0.9082, exactly what we did on top. See, your area is 0.9082 for z-score when z-score is 1.33. Now the other one is z equal to 0.02. So here is 0.0. Now, okay, going to the right, here is 0.2. Okay, and we have this one for 0.02, so I'm writing it. So that is for when z is equal to 0.02, and here this part is when z is equal to 1.33. So this is area. Okay, so I'm using those two and finding the answer for part C. Okay, so area between z equal to 0.02 and z equal to 1.33 is, we need to subtract. So let me write this way better. Okay, so I'm using this method first. You need to subtract. So I have our area So this P means probability or area. So area based on what z-score is. Here for when z is equal to 0.02, we got this one on top. We got 0.5080. And for when z is equal to 1.33, we got 0.9082. Okay, so now finding the difference, I need to subtract. So this one minus 0.5080. Okay, so subtract, the answer is 0.4002. Okay, so I got the answer without using calculator for this part. I want you to learn how to find the answer without using calculator. So if you want to use calculator, you need to use normal CDF. So this is normal distribution. And okay, let me show how to use that calculator. I don't have the software on my PC, so but I can take picture and showing that on. So first, you need to press second on your TI-84, then vars. We did this part before. Okay, let me show that here. Okay. Okay, it's not connected. One moment. Okay, here is what I have. So I press second, then wars. Then you're gonna see this page. The first part here, as you can see, we have distribution. So choosing number 2 normal CDF because we have to enter lower and upper value. So pressing that one. So enter. After you pressed enter, you're gonna see this page. So here is okay. Let me take that picture again. So you're gonna see something like this. But this means native infinite. So I'm going to enter data on this board and see what the answer is. And mean is 0 and standard deviation is 1. Okay, I'm taking a picture of what I have here. So this is what you need to enter. Then after that, press enter, again enter, and enter, again enter to see the final answer. So here is what I have. So see here on this part, normal CDF for lower 1.02 and here 1.33. When mean is 0 and standard deviation 1, the answer is 0.4000. So and using that table we got 0.4002, but if you want to round it, it's 0.4003. So a little difference because that table is not exactly what we have, but using this calculator is better. But you can use either table or calculator, it doesn't matter. Here on this part we got 0.4003. Or if you round to 3 decimal places, we're gonna have same answer as 0.400. Okay, so let's go back to lecture. Okay, so here on this part, we need to summarize what we had on the previous page. So we need to find the area to the left of x. So here I don't have this where I have x. First, we need to convert our value to z-score. And then find area in table or using normal CDF. Okay, now this part we need to find the area to the left of x. As I said, the area to the left of x is equal to 1 minus the area to the right of x. So, sorry, to the right of z-score. So again, since here we have x, we need to find what the z-score is. So convert value, which is x, to z-score. So then the area is the area to the right of z squared is equal to 1 minus the area to the left. Okay, now on this one we have x1 and x2. That means that we have two z scores. Again, since we have value, first convert to find z score. Then the area to the left of x2, which is this part. So starting from this point to this point, minus area to the right of x1. Oh wait. Area to the left of x2 minus area to the left of x1. Okay. So that is what we have in between. Okay. Now, number four. Number four, we need to find z squared such that the area under the curve to the left is 0.2. Okay, so on this part we have area, and we need to find z score. So find z score, and the area is 0.2 or 20%. So the area for all this, as I said, this is equal to 1. Or 100%. And since here we have 0.2, that means this part is 20%. So 0.2 or 20%. This is area. This is what we have here on this part. So the rest of this is 80%. 1 minus 20%, this is 80%. Okay, so we need to find z-score. To find z-score using calculator, instead of normal CDF, we should use inverse norm. So this is inverse norm, and so for this part we need to enter area Then here is mean and standard deviation. This is when you have z-score and you need to find, okay, this is when you have area and you need to find z-score. So on this part, I'm writing it here. The area is given. So find z-score. Or in other words, we need to find cutoff value, which is exactly what we mean for z-score. And on previous part, we use normal CDF, and we entered lower, upper, mean, standard deviation. And this was when z-score is given and we need to find area. So for this part, z-score was given. So find area. Okay, so I want to use table, and here what's given is area. So area is equal to 0.2. So find z-score. And use table. Let's go back to table. Okay, so on this part I need to find, so all these numbers in our table, these are area, and as I said, what we have here on the first column, this is z-score plus what we have on top. So I need to find 0.2 or 20% here in the body of this table. Okay, so here is what I have is 0.2005, and here I have 0.1977. I'm zooming in, so it's 0.2005 and 0.1977. I don't have 0.2, so I'm choosing the closest number I can have to that area. So between these two numbers, the one that is closest to 0.2 is 0.2005. So I'm choosing to have this one. Now going to left, here is the number I have on the left side. On the first column is negative 0.8, and then go on top, because we have this number, go on top. On top I have 0.04. So adding these two numbers, I have negative 0.84. So we use table, and based on table, the closest is 0.2005. What that means, the score is negative 0.84. Or we can also use inverse norm So the first part of the set is, this part is area is 0.2, comma, mean is 0, standard deviation 1. Okay, so let's go back to our calculator and see what the answer is. So again, press second, then bars, then choose normal CDF. So here is my page. So after I press second, bars, then I'm choosing to have this number 3 inverse norm. Then press enter, enter your data. For area we have 0.2, mean as 0, and standard deviation is 1. So here is what I have. This is 0.2, mean 0, and standard deviation is 1. Then press enter, 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 again enter. This is what I have. Okay, I have negative 0.84. Let's go back to lecture. So using calculator, again, the answer for this part was equal to negative 0.84. And this is the score. Okay, number 5. So here the obtaining height of 203-year-old female patients. The height are approximately normally distribution. So we have this one, normally distribution. So that means our mean is 0 and standard deviation is equal to 1. For all of this 200. Okay, now here is example number 5. Here in this part we have heights of 203-year-old female patients. Height are approximately normally distributed. And this part mean is 38.72 and standard deviation as 3.17. So part A use a normal model to determine proportion of 3-year-old females that have height less than 35. So this is what the value is. So that is our x. So first step, we need to convert that value to z-score. So first, okay, so convert our x, which is 35, to z-score. Z is equal to x, or our value, minus mean divided by standard deviation. And that is equal to, so our x is 35 minus mean was 38.72 and standard deviation 3.17. So that is equal to negative 1.17. Now, second step, we have to find area. Area to the left, because here we have less than. This less than means finding area to the left. And this one is our x. So left of z and z is negative 1.17. First, using table, we have to use z equal to negative 1.17. So here we have negative z score. And our answer should be less than or equal to 50%. So before using our table, I'm going to add note here. Then we have negative z score. That means that area should be less than equal to is I used equal to because in table we have equal to 50%. But when it's equal to, z is equal to 0. So it's better to write less than, not use equal to. So less than 50%. And then we have positive z-score for area is greater than 50%. So here between we have z as 0, and right side we have positive z-score. And on left side of z equal to 0 we have negative z-scores. And in total, the area under curve, this is equal to 100% or equal to 1. Meaning that the first half here on right, we have 50% of area is on right side, and 50% the other half is on left side. And the numbers that you may have, so the numbers that you can have for area starting from 0 to that's less than 50%, or we can have 50% using table, so equal to, and here starting from that point 50% to approximately equal to 1. On table we do not have this exactly equal to 1. So these are what we're gonna have. So if in case you have negative z-score but your answer for area was greater than 50%, you can know that you made mistakes somewhere and repeat the process either using table or calculator. And also I want to add something else here that, so these are in general what we use. So again, normal CDF is when we have starting point, ending point, or mean, which is always equal to 0, or standard deviation, which is always equal to 1 when we have normally distributed. And the other one is that using inverse norm. Here, use this one when area is given and asking to find z. So the mean, standard deviation, here again that is 0, this is 1. Use normal CDF when z-score, use when z-score is given and asking to find area. For inverse norm, area is given, so use this one to find z-score. Now back to our example here. Now I want to find area using our table. And z is -1.17. This is -1.1, and top we have 0.07. Add these two as -1.17. So using this row and this column, the answer here is 0.1210. This is not exactly equal to this number because on table all of those numbers are rounded to 4 decimal place. Okay, I'll also draw this. In between we have z equal to 0, and what we have here is -1.17. And asking to find area to the left, which is this part. So the area here we got is 0.1210. Since these are rounded, it's better to use this instead of exactly equal to. Now I want to use 384. So using this one, we have to use, since z is given, asking to find area, use normal CDF. Finding area for this part, here is our lower bound, and this is upper bound, which is z equal to -1.17. So on the left here we have negative infinite. Instead of how we can enter negative infinite into our calculator, it's -1e99. How to enter this e is so to enter that one, press second, then division. This is to enter e. So So comma, we have negative infinite. Here on the right side we have negative 1.17. Mean always 0. Standard deviation is always 1. So let's use our calculator. Press second, bars, choose number 2 as normal CDF, enter. For lower we have to enter negative 1 E99. Again, to enter E you have to press second, then division, and upper is negative 1.17. So we have this. Mean is 0, standard deviation 1, then enter. You have to press enter many times till you find the answer. But this is the answer, is 0.1210. Since on table, rounding to 4 decimal place, I'm doing the same thing into calculator, rounding area to 4 decimal place. So again, the answer is 0.1210. We got same answer. We got the answer using both table and TI 83, 84. Now next one, find the probability that a randomly selected 3-year-old or that is between 35 and 40. So this is between. This is x1. Here is x2. And we have in between. Again, this is x. It's not z. So first step, convert x to z. So z1 is equal to x1 minus mean divided by standard deviation. It's equal to x1 is 35 minus mean is given on top is 38.72 divided by standard deviation also was given as 3.17. I used same mean and standard deviation for part A. So this is 1.17. Since I have our x is 35 and part A we have 35. Here again we got negative 1.17. So this is our z1. Now finding z2. This is equal to x2 minus mean divided by standard deviation. So our x2 is 40 minus mean, again 38.72. Standard deviation is 3.17. So here is 0.4 or 0.40. Now finding area when we had outward x between 35, 40. So that is area when z is between negative 1.17 and here is 0.4. Now area is between. We already have the answer for area when z is equal to negative 1.17 from part A, and that was 0.1210. So writing that right here. Now use table to find the area when z is equal to 0.4 So here is 0.40, and the answer for this one area is 0.6554. Okay, so the answer is what we have on right is 0.6554 minus 0.1210. Subtract. Our answer is 0.5344. So this is the answer using table and now use calculator. This was using table. I'm going to draw this one. Again, in between is z is 0. And here what we have for z is negative 1.17. And here we have 0.4. So we have to find area in between. And using table, the answer we got here was 0.5344. Now use TI 83, 84. Again, we have the score and we have to find area, so use normal CDF. And now in this case, lower bound is negative 1.17, upper is 0.4, mean is 0, standard deviation is 1. Okay, so use calculator and enter these. Again, second was normal CDF. Enter. For lower, negative 1.17 and upper 0.4. So this is what we have. Now enter, enter, enter. Here is the answer. After running is 0.5344. Again, since on table, all these numbers for area are rounded to 4 decimal places, I did the same thing on calculator. And when using inverse norm to find z, since z is rounded to 2 decimal places, I do the same thing on calculator, rounding to 2 decimal places. Okay, here, okay, here mean is 21, so 21 days. And suppose that the times are approximately normally distributed, so we have, again, we have this rule is normally distributed with a standard deviation of 1. So what we have mean is 21, and standard deviation is equal to 1. So standard deviation is 1, and mean is 21. So part A, what is the probability that a randomly selected fertilized chicken egg hatch is in less than 20 days? So what we have here is X. And we need to find probability, and probability, as I said, is exactly same as area proportional. So since we have probability, use P. We have X, and here we have less than. So less than 20. So first step, again, we need to convert that one to z-score. So z is equal to x, which is 20, minus mean is 21, divided by standard deviation is 1. So this is equal to -1. Okay, then, so this is equal to, now instead of this x, I'm using z. So probability of when z is less than -1, that is equal to, let's try this. Okay, so this point in between is 0, z is 0. Now we have on the left side of it, we have negative number, and right side we have positive numbers. And here in this case, we have -1. So let's have this one here. So z -1. And we need to find, since we have less than, we should find the area to the left. So less than -1. Find area. Here again, we can use our table. So z equal to -1. So these are positive numbers. Here we have negative numbers. Z equal to -1. So here is what we have, -1.0. On top we have 0. So z equal to -1 is 0.1587. That is area. So using table, the answer for this part is 0.1587. Let's say you didn't have access to the z-score, to these negative numbers. You only had a table for positive numbers. What you can do? Okay, even if you didn't have access to negative numbers, you can find the answer. So that is equal to, so p z less than -1 is equal to probability of when z is greater than, so I'm changing the this symbol in between. So here is less, I'm changing that to greater. Instead of using -1, I'm using +1. So that is equal to, So since we have greater than, that means that we need to find the area to the right. And to find the area to the right, you need to use that rule and subtract. So subtract that from 1. So 1 minus what we have to the left. To the left of z. So this is to the right, and here is to the left. So to the right, this is left. Now you can use table, and if you had only had access to positive numbers, you can use that part only. So 1 minus, when z is equal to 1, use table is area is 0.8413. And the answer again is 0.1587. So you can use either method, this part or this part. So that is or. So either this method or this method. Okay, part part B. What is probably that random selected is over 22 days. Okay, so our probability on X is greater than, because we have over 22, so greater than 22. So here again, first step, find z-score. So our X minus mean, here in this case, X is 22 minus mean is 21 divided by standard deviation is 1. So here we got 1. So z is equal to 1. So that is equal to probability of when z is greater than 1. And we already know the answer from what we got here. See, we exactly have same thing. So we're going to have exactly same answer that we got here on top. So z greater than 1. So first, let me draw this. It's kind of hard drawing, huh? So I'm redrawing it. Okay, much better. Okay, so z0, and here we have 1. So z equal to 1. And since we have greater than, we need to find the area to the right of z. Since we have the area to the right, we need to subtract. So area for this part, that is equal to 1 minus area to the left. So that is equal to 1 minus area. So this is area to the right. Here is area to the left. So 1 minus use table z equal to 1. The area is 0.8413 and that is equal to 0.1587. What that means here, okay. So area from this part, okay, let me choose different color. The area starting from that point up to this point, this is what we got here as 8.8413. And here on this part, the area is 0.1587. Okay, so we finished that for now. Part C. What is probability that we have our values between 1921. Okay. So our x is between 1921. So convert to z-score. The 1 is equal to our x19 minus 21. Standard deviation is 1. So that is equal to -2. Now z2. So x is, here we have 21. So this is x1. This is x2. So x is 21 and mean is also 21 divided by standard deviation 1. So here is 0. Now go back to this part, so we converted to z-score now, using that z-score to find area. So finding the probability that when z is between -2, 0. So here we need to subtract when z is equal to 0. So let's go back to the table. And z is 0. Okay, so here is z equal to 0 and the answer for area in the body of table we have 0.5000 or 0.5. And when z is equal to -2, so we need negative numbers. Okay, so here is -2 and the answer for area is 0.0228. So I'm using these two numbers. Okay, let's write this way so you can better understand it. So probability of z-score, now that is between when z is -2, using table the answer is 0.0228, and when z is equal to 0, the area is 0.5000. So we have this part. Now we need to subtract. So subtracting what we have here, 0.5 minus 0.0228. So subtract, the answer is 4772. Let's also draw this. Okay, so on this part we have z equals to 0, and here we have -2. And we should find the area in between. So using table, we got that the area for this part was 0.0228. And the area for this part, okay. To this point, the area was 0.5000. That's why we need to subtract to find the answer for this part. So 0.5000 minus what we have here, we can find the answer for this part. Okay, part D. Would it be unusual for an egg to hatch in less than 18 days? Why? Is that unusual? And here we have 18 days. So here is X. So we need to find probability of when X is less than 18. Because here we have less than. So again, first step, find z-score. Z is equal to X minus mean, which was 21, divided by standard deviation, which is equal to 1. So z is -3. So finding the area when the area or proportion or probability when z is less than -3. So using table, when z is equal to -3 is 0.0013. Or if in case you didn't have access to the negative numbers, once again, so z, when that is less than -3, this is equal to probability of z. Now instead of less than, use greater than. Instead of negative number, we have +3. Since this is greater than, this is the area to the right. So that means you need to subtract. So 1 minus the area to the left. So 1 minus. Now use table, and when z is equal to 3, the area which is in the body of table is equal to 0.9987. So subtract, here we got exactly the same answer as 0.0013. Okay, I'm going to draw this for this part again. So here we have -3, and this is +3. Because here on this part you use -3, and on this part you use +3. Well, we got the area less than -3. This was equal to 0.0013. And same thing for this part. When z is greater than 3, we got exactly the same thing. Now it's asking if this one is unusual. Remember, if the answer was less than 0.05, then yes, that is unusual. So since we have 0.0013 less than 0.05, so yes, unusual. Okay, number 7. So we assuming that the random variable x is normally distributed when mean equal to 15, no, sorry, equal to 50 and standard deviation is 7. We need to find the percentile for x. Okay, so part A is 9th percentile. What that means, here area is equal to 9%. Okay, so first step, find z, then solve for x. So here we have mean as 50 and standard deviation is 7. And we need to find the area when z is less than, I don't know that part, and actually that probability is given. So the probability is given and we need to find out z is less than what number. So probability or area is equal to 0.09 or 9%. Okay, let's add note on this part. Since probability is less than 0.5, 0.5 or 50%. Let's say the area for all this is equal to 1 and that is equal to 100%, and here we have 50%. So half of it is 50% or 0.5, and since here in this case probability is 9%, what that means is area is somewhere here, so it's less than 0.5 or less than 50%. So we have what that means. Remember I said here we have z is equal to 0. Since that is less than this, z equal to 0, we should have a negative number for z. So negative z-score. Okay, now you table it. In the body of table, you need to find 0.09. Okay, let's go back to. Yeah, I said we should have negative numbers. So negative. Okay, so here is the number we need. In the body of table, here on this part we have 0.0901, which is the closest one we can have to 0.09. What that means, here to the left side we have negative 1.3, and going up we have, this is 0.04. So adding these two numbers we have negative 1.34. So that is the number. Here's the number I have, and here I need to add that one. What is that? This one. So we have negative 1.3 plus that number, we have negative 1.34, and the area is 9%. Okay, so that means here z is less than negative 1.34. Okay, so I'm writing it just z is equal to negative 1.34. Okay, now part B. On this part we have 90% because it's 90 percentile. So here is 90 percentile is area is equal to 90%. In this case, probability is greater than 0.5 or 50%. What that means, z-score is positive number. So probability greater than or equal to 0.5 or 50%. What that means, use positive z-score. Okay, I'm trying this one. Since we have positive, so in between we have 0. This is kind of okay. Let me retry. Okay. So Z should be somewhere here. Z, you don't know what Z is? And here is Z is 0. And we need to find, okay. Okay, so here is what we have on this part, probability of Z less than, I don't know what that part is, that is equal to area is given as 90%, and we need to find Z. Okay, going back to our table. Actually, I didn't finish part A, so I'm only working on finding Z first, and then I will find what X is for each part. Okay, so this part we need to find what Z is. Here in the body, we need to find, okay, we have positive numbers for Z score. So we need to find 90%. Okay. Okay, so I have these two numbers. I have 0.8997 and I have 0.9015. We need to choose the closest one to 0.90 or 90%. So this is closest one. I'm not choosing that one, so I'm choosing this number. Then, so that is the closest to 90%. Going to left, here we have 1.2. And going on top, here is 0.08. So adding these two numbers, we have 1.28. That is Z score. Okay, so Z is equal to, okay, so here is 1.28. So now that we got our Z for part A and B, so see, first find Z and we got Z, then we need to solve for X. So I'm writing part A here in this part. For part A, I'm using this part. So now use Z equal to X minus mean divided by standard deviation and solve for X. So for Z here, we got negative 1.34. Negative 1.34 equal to X minus mean is 50 and standard deviation 7. Okay, solving for X. Since we have this denominator, I should clear that. So we can multiply by 7 to clear this. So all of this multiplied by 7. So we have 7 times negative 1.34. That is negative 9.38 equal to x minus 50. And solving for x, you need to add 50 and here also 50. So x is equal to 40.62. Okay, so I added 50 on this part. So that was for part A. Now finding the answer for part B, the final answer. So we need to find x here again. Okay, so use z equal to, so z equal to 1.38, then solve x. So we have x minus mean divided by standard deviation. Okay, so using this one, then solve for x. Now z is 1.28 equal to, finding x, and mean is 50, standard deviation is again 7. So here again, you can multiply by 7 all of this, or use cross product. So 7 times 1.28 equal to x minus 50. Okay, here denominator is equal to 1, so equal to 1 times x minus 50. So what we have is 8.98 equal to x minus 50. So solving for x, x is 58.96. So here is the final answer for part B, and this was for part A. Bye-bye.